In the last video, I wanted to go over calculating the portfolio variance, not using this approach, mainly because I myself find it difficult to understand. I don't view variance in terms of multiplying matrices together. Some people can easily see it. This is basically what we're doing. I'll give you guys a link as well of where I'm grabbing this tutorial. It's something you can easily find online, but effectively when you're calculating the variance, you're going through this form of multiplication. It's not something that comes naturally to me. So what I do is I back into the numbers, and once I set everything up, which I've done over here, the long way around, I back into this formula, and I'll give you this formula as well. But I recommend don't just copy and paste stuff into your models that you don't understand. Also, I come from quality assurance background, so I've seen a lot of models. I myself have built them, and I built mine quite simply. A good thing is because maybe I didn't know Excel that well, but that's a good thing because you learn your basics, you learn the arithmetic, and I'll show you how the devil is in the details. Knowledge is in the details. So here, let's play around with Lockheed Martin and Akamai. The rest of the assets I've forced to be 0. This is my basket of assets, and the best asset mix that gives me the greatest return and the lowest risk for that return, that's what I'm solving for. That's the minimum variance frontier, the efficiency frontier. So I'll do a 60-40 blend, and I'll back into these numbers here. I'm doing Ctrl G right now and quickly going to 027. Makes your life a bit easier when you have big models, big Excel books that you have to go through, or sheets where you have data in thousands of columns. So Ctrl G, and then plug in over here on the reference what your cell is. We are going to back into this number, variance. This is your variance. Actually, this is the standard deviation calculation of a portfolio. And you see here we're doing weight squared times the variance of asset 1, weight of asset 2, times the variance of asset 2. And then you will see a lot of this go on, which is basically the correlation, standard deviation of 1 and 2. That's your covariance, and that's what we have been doing here with our portfolio matrix. We've been solving for the covariance. And remember, pairs, Lockheed Martin, Akamai, pairs, these are the variances. This is the variance of Akamai, variance of Lockheed Martin. But this is over here, the covariance of Daimler and Lockheed Martin. Covariance of Lockheed Martin and Akamai. Going back to our calculation, the way I'm approaching it, I just did, okay, here's Akamai, Lockheed Martin. So what I need to do is square these weights. I'll then add Disney, but let's just start with a mix of 2. This is me testing my setup of the model. Akamai, Lockheed Martin, 60-40% investment. I square this weight. For Akamai, I square the weight of Lockheed Martin. This is this equation and this equation, square and square. And these are variances. So what I end up doing is go Lockheed Martin down here and grab the variance of Lockheed Martin. I grab the variance of Akamai. Let's just assume that we feel confident in our calculations here of variance and calculations here of variance. And I'll show you then why the devil is in the details. I wonder if you notice something here right now. So here I'm grabbing variance and variance. And what we're going to do in the first equation is calculate variance and variance times squared weight and squared weight. So I'm doing this and I'm doing this piece of the calculation. Weight squared times the variance of asset 1, weight squared times the variance of asset 2. So in this case, it's weight squared Akamai times Akamai here variance, weight squared Lockheed Martin times Lockheed Martin variance. So that's the first set. And then I need to grab this piece here. 2 times the weight of 1, weight of 2. Notice it's not weight squared. It's weight 1, weight 2 times the combination times the covariance of the pair. And what I'm doing here then is grabbing, let's get rid of this pair. I want to add a third asset later. So right now these are zeros and not giving me any problems. Actually, let me turn them off for sure. So I'm doing times 0 and times 0 here. Instead of wiping out the formula, I'm placing this to 0. So I'm just turning the thing off. And what I'm doing then is taking this calculation, this 2 weight 1, weight 2 covariance, which is, if you see, 2 times weight 1, 60%, weight 2, 40%, times, and under portfolio Q7 is the covariance. Let me just show you what Q7 is. Control G, Q7, click enter. Q7 is the covariance Lockheed Martin and Akamai from our matrix. So this cell is this piece of the equation. And under variance here, I'm adding this piece of the equation and weight times variance, weight squared times variance, which we calculated down here. Notice, by the way, the square root here means the standard deviation. We're looking for a variance. So go under portfolio. I'm not tying. Okay, so it's 2.6%. If you remember earlier, I said devil is in the details. When you are using formulas like this, you got to feel comfortable. Where's the information coming from? How is the system calculating this? Well, in this case, this is a daily variance, and I am looking for 250 days in a year form of variance. I'm annualizing it, and I will do this by multiplying my variances by 250. So either I can multiply up here times 250, or I find it a bit easier multiplying it down here. So I'll do this guy times 250. So we are saying Lockheed Martin is 60, Akamai is 40. Lockheed Martin Okay, let's go back. So Lockheed Martin is 60 and Akamai is 40. And I go under indirect and index. Akamai is 40. Lockheed Martin is 60. So I hit flip-flop here the weights. And if I go back, I put to the calculation of variance 0.0266. Control G, 27, 0.0266. Let's do the same calculation, but using 3 assets now. You do the same calculation with a 3-asset mix. You need to see a covariance for 1 and 3 and 2 and 3. These are combo pairs. When you do 4 assets, you would do 1 and 2, 1 and 3. Here, just to give you an idea. So right now I did one combo pair. 1, 2, Lockheed Martin, Akamai. Let's say I add Disney. I need to do a Lockheed Martin, Disney, Akamai, Disney. Let's say I add BlackRock, which would be 4. So I'll do 1, 4. I then need to do 2, 4, and I then need to do 3, 4. So you see the combo pairs starts increasing a lot faster the more assets we're adding to our basket. And what we're trying to do is find the best asset blend that will give us a return at the lowest possible risk. Right now, we are just double checking this piece here so that it makes sense. If you ever presented me with, let me go back to this matrix, I still don't fully understand it. In fact, it just doesn't come naturally to me. I don't see the numbers in this way. And if I don't understand the numbers, I go see a different approach for getting the same result. So if I can get the same result my way, the way I understand it, then I'm comfortable with you providing me a model that looks like this. So now we're going to add a third asset. We'll add Lockheed Martin at 60, Akamai 20, Disney 20, and trim back into 0.023 variance. We'll go under here, do Akamai, Martin. This is just to make sure that I'm pulling these in properly. Disney 20. All right, so we're changing up our asset mix, 60, 20, and going through this calculation again. We're doing 3 now. You can just imagine how it gets when you're playing around with 4, with 5, and we have 10 here. We'll add Disney. This is just as a precaution to make sure that we're understanding this portfolio variance. This matrix here, we want to get to 0.237, and we want to do it the long way around. 0.237 works this route. And I'll show you how you can set it up as well like this. So for instance, here's just pulling in our weights. Here's pulling in our variance. Notice our variance is coming from here, from our matrix, and it's the covariance pair of the same asset, which ends up being your variance. Devil in the details, multiply by 250. This is our weight squared. This is our variance. And then here is weight squared times variance. Weight squared times variance. Here and here, these calcs. Going back to portfolio. We're doing the second piece, that's 2 times weight 1, weight 2, covariance. Weight 1, weight 2. And then it's basically the summation of it. So here's the last formula. These are just different ways of getting to the same result. So here's the formula. You're adding the matrix. And then the sum of all this plus your weights, which was the first piece of the calculation, these pieces, and the matrix is all this combo pair, 2 times weight 1, weight 2, covariance. This entire thing is that section of it, but we're saying for 10 assets. So you're summing that up, and then this first section, weight squared times variance. The sum of these two equals your portfolio variance. Do it the long way around here. We wanted to do Disney squared. Here we need to add 1, 3, 2, 3. So we need to add Akamai, Disney, Lockheed Martin, Disney, combo pair. And then activate these pieces here. Go back, add weight squared Disney times variance Disney. Here's variance Disney. Enter. Let's go grab variance Disney times 250. And there you see our result is 0.237. Let's just bring in this variance to show you. Variance Disney from our matrix. Enter. Here's our result. Of course, I like using pink, so I'll make the extra effort and use the pink here instead of the yellow. 0.237 portfolio variance. 0.237. I hope this is helpful. I am going to give you this multiplication quick formula, but I suggest do it yourself. Do it the long way. Do it with 2, with 3, with 4, and then you get an idea of the complications of having 10. The next tutorial, I think what I'd like to do is a bit of VBA. I'll create a macro where I automate pulling in additional day returns automatically, and then I want for it to come up here and change my name ranges. So I want for it to add anything new and then create from selection and change all of these name ranges. So right now you see Disney's name range, just here's the name range, just ends at row 170. I want for it to know to go to 176. The reason for that is because when we build our matrix here, our covariance, we are using these arrays. We need the name ranges. That's next. If these are helpful videos, you find them useful, click the like button, click the subscribe button. I have a small business, it's called jazzfin.com. If you need anything specific, contact me either through there under the contact us tab or the comments below. Okay, till next one.